All right, let's now talk about reminders. Your programming test number 1, the marks, the feedback file, and also your original submissions that you made during the test, and the grading test that we used to assess your work, they have all been released. So take the most advantage of it. So I would suggest maybe look at exactly the test cases your submission failed and try to fix them. And then if you got time left, maybe not just for programming test 2, because we still got other assessment coming. You may want to consider redoing your programming test 1 by having the same time limits. That's something I'll leave to you. If you want to discuss any particular implementation details for programming test 1, reach out. I'm always there, the office hour. And for your programming test number 2, it's going to be tomorrow during your enroll lab session. Make sure you come in time, and then we'll start in time. The same rule, I'm going to send you some reminder later today, but there should be no surprise in terms of the rule. Okay? And by the way, there's a programming test guide for this one here. If you haven't checked, I would suggest you check so you don't miss any important information. And don't forget your lab number 3 is actually due this Friday. All right? So this is the only lab where you only got 1 week to complete. It's because it's simpler than other labs, but for lab number 4 and 5, you'll definitely be given the 2 weeks window, again, to complete your work. But I think for lab number 3, given its simplicity, I think 1 week is just enough. Right? Just finish that, claim your credits, and then we'll move on. And on Friday, I'm also going to release a solution and grading test to you as usual. So you can also try to explore further the lab yourself. All right, any question about the course in general? Anything you want me to clarify? Yeah.
How to add the grading test into the programming test?
Grading tests, basically, they are not really Eclipse folder, just regular folder. I would say just copy the file, like individual JUnit test files, and into the JUnit test package of your starter project. As easy as that. No trick, all right? But if you have trouble importing them, let me know. I can help you, all right? Yeah. All right, guys, any other questions before I dive into technical stuff?
So just to make sure, programming test 2 is going to be very similar to programming test 1, just with addition of a few exception stuff?
Yeah, you can think about conceptually, yes. Programming test 2 is like a programming test 1 plus exception. You can think of it. Of course, it's going to be a different problem that you have to solve. But I would say more or less the same. Okay. Yeah, good. Of course, we'll still assume you know the basic OOP stuff, right? Plus exceptions.
So if we did all right on the first one and we're happy with that mark, then we just need to brush up maybe on...
Yeah, I would suggest, yes. Maybe try to brush up your basic OOP. You can go back to lab 1, can go back to lab 0, part 1 and part 2, and can go back to the PDF notes that you actually studied before. Yeah, I think any brush up is going to be useful, for sure. All right, any other questions? Alrighty. So today, the plan will be, based on my lesson in the morning, we should definitely finish the equals method. I want to go over a more sophisticated example of equals method using array. And then I want to talk about a small topic called call by value, which is also very important. And then we're going to continue to finish everything on Thursday, and then we can move on to inheritance. All right? I'm very excited. Not yet, but let's look forward to it. Let's now recap what we actually spoke about from last week very quickly. And we'll see what we should build on top today. So we basically just talk more. Did I go over? No, should be good. Yeah, so last Thursday, we basically just went over more example about JUnit test assertions, assert the same, assert equals, right? So you want to really go over the definition and also the equals method example, right? So I'm not going to repeat the details today, but if you need to clarify, drop by, and then we'll talk. And we spoke about the short circuit evaluation in Java. And the short circuit evaluation is not unique to Java. If you use any other programming language like a Python or maybe C#, they also got similar logical operator. They also got short circuit evaluation, right? It's not 100% equivalent to math. You want to keep that in mind. And we spoke about the truth table, which talk about how you can understand the short circuit evaluation. Always remember, it's from left to right. For the AND or operator, right? So just make sure you review the relevant details. And we spoke about conceptually, you can think about the left-hand side being the guarding constraint. If the guarding constraint is not true, in that way, we're going to skip the right-hand side. We're not going to evaluate it even. On the other hand, for the OR operator, you can think about this condition here is more like an error condition. If the error condition is actually true, in that way, we also skip the right-hand side over here. So we can avoid running into any crash or exception. And I also gave you guys some exercises to try out. Right? I would say, think about it, work out your answer. If you are not confident about it, drop by and we can talk. Okay. And this exercise over here, just to say, if you kind of swap the order of the condition for short circuit evaluation, it can make a difference. For example, if you try to trace the code over here, in both cases, it's simply going to crash. Right? You're going to see exactly how. But if you try to swap the order of these two conditions, you can safely protect it. Right? So the order really makes a difference. That's the main message for you to get. And we apply the short circuit evaluation to combining these two conditions in the equals method, and we talk about which option should be chosen, right? You can also refer to the recording to see which one should be chosen and why. And let's see. And this is where we kind of stop, right, on Thursday. So we had two classes over here to worry about. One will be the person class. The other one is a person collector class. So let's have a very quick brush up, and then we should continue. Hey guys, over there, I can hear something. Please. We want to be as quiet as possible for your classmate. Okay? Okay, so we got the person class over here, which got attributes, first name, last name, weight, and height. And then we got the equals method, and then that one there is just going to compare all the four attributes one by one. Okay? And then we got another class called person collector. Let's take a quick look. So person collector has an attribute of type array of person, and also got some integer counter. Let's assume the collector is as simple as that. We don't have any additional attributes. Okay, only two. And we got the constructor, mutator, accessor. It will just work like how we study about a programming pattern. No surprise. That's why I don't give you the details over here. And the equals method here is going to do something very similar. So the first two lines are just standard, right? That one there we can skip. And we might need to do a little bit of casting here because OBJ, again, object static type, cannot really invoke any attributes in the person collector, right? The same reasoning as we said earlier. And let's now try to understand once more. I kind of briefly walk through about the logic over here. So the equal here is a Boolean variable. That one there is going to help us control whether we should go into the loop for more iteration, or should we exit from the loop and stop right now. What's the idea here? Okay, let's look at some diagram here, which we're going to run into. At a runtime, this is as complicated as you might get. Okay, let's say we got two person collector objects here, PC1, PC2. And both of them, each one of them has a separate array because the person's array is a non-static attributes. That means every person collector object has a separate array over here. Let's say the array has maximum size 100, let's say. And then if I want to ask you about whether PC1 is equal to PC2. So here is how the idea should go. Number one, we look at the counter, right? At this point, they are the same. But what if, let's say, one has the counter 2, the other one has the counter 1? That means one collector stores two persons. The other one stores only one person. In that way, it's easy decision making. You just return false for the equals because they cannot be equal by storing different numbers of persons. Let's say they are storing the same number of persons. Let's say 2 here and 2 here. Then what should we do? The idea goes like this. We want to go over the array from left to right and from left to right. Compare index-wise person that's stored. For example, for the very first iteration, when loop counter I is equal to 0, look at index 0 here and index 0 over here. If the person's objects here and the person's object over here, they are the same by equals method that's defined in the person class. If they are equal, And then we go ahead and compare the next index and so on. As soon as we find out, for example, let's say index 2 is pointing to this person here, index 2 is pointing to this person here. Let's say these two persons somehow are not equal. Maybe they have different first name. That would be the very first instance where we see some unequal person between the two collector. In that way, we are going to set the equal variable here to false right away. And as soon as we got equal here being false, and the condition here for the for loop, because conjunction here, this will be false, the whole thing is going to be false. Once this becomes false, no more iteration should be run, and we can exit from the loop. And once we exit from the loop, we can just return the value for equal, which will be false. That's kind of the conceptual idea of the different scenario you will have to go through, well, we have to go through today. But before that, I'd rather you have some big picture. So the critical thing is, you want to understand, number one, how this Boolean variable really is being used. And number two, exactly how many iterations do we really need to run to determine if the two person collectors are equal or not equal. We're going to see different cases. Right? So these are the questions you want to ask yourself when you actually review the lecture material. And one more thing before we talk about the new stuff for today. We analyze this expression here, right? Like a this dot persons I dot equals. And we analyzed and concluded that this equals method here is referring to the equals method in the person class. Right? If you got any doubts about it, please refer to the recording from last Thursday. It is important for you to know which version of the equals we are calling. Okay? All right, any question so far? It's so far more like a recap, but we're going to build on top right away. Any point you want me to clarify before I move on? The last bit for the equals method, no new knowledge should be learned. We just want to trace this example to make sure you're comfortable. That's all we're going to do. Could be a little bit dry, but let's try to stay on top of what's happening here. There are different scenarios. I'll try to keep reminding you about the big picture. All right, let's now trace it. So 1, 2, 3, 4. 4 pages we're going to do. Okay, let's be patient. Page number 1, pretty easy. We want to compare if two persons are equal. We're not even talking about person collector just yet. Let's warm up. All right, very easy. So now let's say we want to create P1, P2, P3, and P4. All right. Apparently, we got only 3 new objects to be created. Let's create them. So for P1, AA180.1.8. AA180.1.8. For P2, AA180.1.8. The same contents. AA180.1.8. And also for P3, BB200.2.1. BB200.2.1. As soon as you have done the as soon as you have done the creation of these 3 objects, you can already see something informally. P1 and P2, even though they are different objects, but their contents attributes are just the same. On the other hand, for P2 and P3, for example, they are different objects, yes, but at the same time, you can see the contents are also different. Right? You want to kind of observe that right away. Finally, we got P4, which is not going to trigger any new object creation. It's simply just going to let P4 pointing to wherever P3 is pointing to. All right? That's what we're going to do. All right? And let's now talk about how we can compare objects. Let me do it in this order. Can we first consider P1 equals P2, and also P3 equals P4? These two should be quite straightforward. P1, P2, not the same objects. P3, P4, the same objects, right? Obviously, P1 equals P2 should be false, not the same objects. P3, P4, they point to the same object, aliasing. So that should be true. Right? So these two are easy. Let's get rid of them right away. The next two will be interesting. Okay, I'm going to write them out. I got here and also here. So start here. We got P1 dot equals P2. And for star, we got P3 dot equals P4. All right? And let's look, both lines are going to call the same version of the equals. How did I tell? P1 over here, dynamically is pointing to person. P3 over here, dynamically is also pointing to person. So I know that in both cases, they are just going to call this equals method here. But maybe different parts are going to be executed to return the result. But the same version will be called. That's something we want to observe right away. And let's now take a look at P1 and P3. Why don't I let you guys stare at this for just one moment over here. This one here and this one here. All right? I can already tell you P1 equals P2 is going to be true. And also P3 equals P4 is also going to be true. That's something I can tell you right away. But this is my question. Is the same part of the equals method in the person clause going to tell you the result should be true? Or different parts are going to tell you the equal should be true? Which part? Okay, think about it for 1 minute. If you can tell me exactly how the star is returned true, from which part of the equals, and star star also returned true, but from which part of the equals method, that'll be useful. You can see how important it is to do tracing, right? Okay, 20 more seconds, and then I can see if you got any thoughts to share before I share mine. All right, anybody would like to share? Yes.
For P1 equals P2,
Mm-hmm.
the reason why it's true is because it fulfills all the conditions.
You're saying this one is okay. Basically you're saying that this if branch is not the case, and this if branch is also not the case. Because P1 and P2, they are not the same objects, but they have dynamic type the same. So you're going to execute this part here. And then when you execute this part, is it going to return true to you? It's going to return true because A is A is A, and this value are the same. Right? That's what you meant to say. Very good. Why don't I follow up by saying, how about star star? Is it going to be the same part that's going to return true for you? But P3 and P4, they refer to the same object which has the same attribute value. If not, then which part? You're saying this line here? Aha, good. All right, so that's really the answer I was looking for, but thank you. So let's say this. What you really want to understand is this. When you try to call this line here star, that one there is actually going to rely on this part here returning true, because we're talking about two different objects. Right? That one there is going to return true back to you. On the other hand, if you try P3 equals P4, because we have the same objects over here, the same. In that way, when you execute this line here, so that this will be P3. The OBJ here will be P4. And P3, P4, the same objects, so this condition here will be true. So we're going to return true. So the final outcome for these two equals method call will be the same, just return true. But you got to know which part tells you it's true. That's the main thing I think you should understand. All right, question. All right, let's now move on to scenario number 2. And now we want to bring person collector into play. All right, let's see how we can do that. So we got basically two person collector object, PC1, PC2. And the constructor here is going to do the routine stuff. It's going to initialize the person collector objects. Number of person will be 0. And then every slot in the array is going to be null. And similarly for PC2. Right? That's not surprising to us. And let's say after these two over here, we want to compare PC1 equals PC2. That one should be false. They're different objects. All right, this one should be no surprise. That should be false. Different objects. And we want now to understand this line over here, PC1 dot equals PC2. And which version of equals should we call? You can see PC1, the context objects, dynamically is pointing to person collector over here. So that means the equals method from the person collector class is going to be invoked. Right? That one also is something we spoke about earlier. So what we should do now is to trace this code here a bit and figure out what the answer should be. Again, I'm going to give you guys just 1 minute. Right? I would like to know, number one, should PC1 dot equals PC2 return true or false? Number two, I would like to know which part of the code tells me that this one should return true. Okay, think about it. Just wait for 1 minute. Huh? It's a question. Go ahead. Okay, it's a subtlety here. No problem. So the question was, how can this assertion pass? The reason that it passes is whenever you're saying assert false, you are expecting the exception. When you're saying assert false, you're expecting this expression here to be false. And because I know that this one is false, assert false, false is going to be pass. If you change this, that's a good question here, but if you change this guy here to be assert true, for example, then this assertion is going to fail. Because you're asserting this guy here to be true, but it's going to be false. Okay? Good. Okay, I'll give you guys one more moment. I still would like you to think about how this PC1 dot equals PC2 is going to be executed. But I'll give you a little bit help over here. If I try to execute this part here, let's say the star, I know that it's not going to return true over here because this and OBJ, PC1 and PC2, they are not the same objects. And also I know that I'm also not going to return false over here because number one, you can see the PC2 is not really null. And also PC1, PC2, dynamically, they have the same objects. Dynamically, they have the same types. Get class and get class over here are going to give you the same class, which is person collector. So it is important to know this one, no, this one, no. So ultimately, we're going to execute basically this part over here. And now I want you to focus on this part over here. Now, is this part somehow work out an answer for true or false? That's the question. Given that the PC1 and PC2, they are both storing no persons at the moment. Anyone? Yes.
So we're just trying to check if it's true or false for this. Okay.
Yeah, so tell me the final answer first. Is it going to return true or false in this case? True, okay, that's good, I agree. But now, can you tell me which part figure out it should return true?
So since they both don't have any persons inside, their NLP are both equal to 0.
Sure.
So we initially said it's false, but then we jump into the branch that also says true.
Sure.
But then since we try to go into the for loop, but then NLP is equal to 0, and I initialize the it never goes into the branch anyways. So there's no pointer exception in that case, and then we just go.
Yeah, pretty perfect. I like it. Thank you. But if you don't mind, let me repeat again for everybody else. So what's happening in this case over here is actually trivial, but very important to note, right? So this is what we call edge cases, like an edge case that can really test to see whether your for loop it really works. Maybe your for loop works for most of the cases, but not an edge case, right? Let's take a look. So what's happening here is just remember, for both NOP here, both 0. So in the beginning, equal will just be false. However, since the NOP and NOP here, they are the same, both 0. So that means we're going to reassign the equal to be true. So this is the value we get, right? And then when we try to check to see how many iterations we should really run for this for loop here, for the very first time, equal is currently true. And then I is 0, initial value. And this .NOP is basically PC1.NOP, which is 0. So now if you evaluate 0 less than 0, it's going to give you false. So if you try to evaluate this n, true and false would be false. So you get false condition right away for the for loop. That means you don't even go for the first iteration. Not even the first iteration. All right, so we don't really execute this. And then we're just going to return whatever value equal was last assigned, which is true. All right, so that's the final answer. All right? It's really important for you to see how exactly we'll work out the answer. Okay? Any question about this? All right. Okay, we're done with 2 cases. Now, number 3. Number 3 might take the most work. Number 4 is more like a very small extension. Number 3. Okay, let's pay more attention on number 3 here. The idea goes like this. I'm going to create ultimately, so given that we have already created P1, P2, P3, and P4 from the scenario number 1, we're now going to gradually add each one of them, or some of them, into the person collector. And then as we have added more person into the person collector, we want to compare their equality right away, right? And see how the code should be traced. Okay, let's now take a look. Okay, I'll make it slightly bigger over here. Let's go over very quickly, okay? So you know the flow. So PC1 should be adding P1, and then we compare equality right away. And then we add another person into PC2, and then we compare their equality. And then after that, we add P3 to PC1 and P4 to PC2. And we try to evaluate the equality for the 3rd time. So there are 3 lines we're going to trace. Line number 1, and line number 2, and also line number 3. These are the 3 lines I would like to check. As we add more and more persons into the person collector, we want to check at the intermediate point whether they are equal. All right, that's something for us to figure out. Let's start with the first one. So for the first one here, it is after we have added P1 into PC1. So P1 is over here. So if you want to add it to PC1, according to what we learned in the pattern, so at index 0, rather than pointing to null, it's now going to point to wherever P1 is pointing to, exactly here. And then you should update the counter from 0 to 1. All right, so that's the first update we'd like to do. And after this updates, we want to compare equality right away. So now at this point, if I say PC1 equals PC2, what should that be? True or false? Well, it should be false, right? Because you can see NOP is already different, so easy. All right. So I just want to highlight to you which line is going to execute. So it's going to execute until this point over here. When we get to this point over here, this .NOP will be 0. Sorry, PC1.NOP will be 1 and also 0. Apparently, it's going to give you false. In that way, you're just going to return right away. Return false. Right? I'm tracing maybe not to 100% detail, but you see the idea, right? All right, so this guy here is going to give you false. Okay? This one's an easy case. You're simply comparing 2 person collectors storing unequal numbers of persons. And let's now try to make the count equal. And let's see what's going to happen. So to really set up the second one, let's now try to say, I want to add person P2 into PC2, right? Into PC2. And then I'm going to assert the equals again. Let's now do this update first. So you can see P2 is over here, and we want to add it to PC2. So standard. So rather than index 0 pointing to null, it's now going to point to wherever P2 is pointing to. And of course, don't forget to update the counter from 0 to 1. Now we got equal counts. And this case, is it going to be true or false? True, okay, but let's see why. Conceptually, they have the same count, which is good. So we're going to compare index-wise. Index 0, index 0. Now, this person and this person, we did some similar exercise earlier. So you can compare A to A, 180 to 180, and etc. So they are the same, all right? So this one here is also going to give us true, but for a slightly different reason. So for this one here, let me just say star, star over here. So for star, star, think about I initially is going to be 0. I initially is going to be 0. Potentially, you can run all the way to the count. In this case, you will only run up to 0 because you got count being 1. Right? When I is equal to 0, we're going to execute for the first iteration. Let's write this out to see exactly how to compare that. So this one tells you equal is reassigned to. So this is PC1. PC1 dot persons at index 0 dot equals, and then other would be basically PC2. PC2 dot persons at index 0. All right, just notice that I'm only tracing the very first iteration, 0 and 0 index. All right? Now, how do we visualize it? So PC1 dot persons at index 0, PC1 persons at index 0 is pointing to this person object here. And PC2 dot persons at index 0, PC2 persons index 0 is pointing to this object. So again, we boil down into comparing the equality between these two persons using the equals method from person class. That's why we talked about this line last Thursday. Okay? So this equals method will be from person class. And that one there is going to compare A to A to A, and etc. Right? Same. So that's why it's going to return to you true. Right? That's the second equals we're calling. Okay? Hopefully you're still here. Not too much lost. Okay? But I'll recommend once you get an idea from today, the 100% detailed tracing will be really up to you. Right? You really want to make sure you understand every detail in the example. Let's now do one more. Let's say we add P3 to PC1 and P4 to PC2, right? Let's update the diagram right away. But this one should be easy. P3 and P4, they point to the same objects. So we are really adding the same objects into two arrays separately. They do have some sharing. And the way to do it is like this. So now it's going to be an index 1 here, and also index 1 over here. So let me use this color here. So index 1 is now going to point to, maybe I should use the orange. Index 1 is now going to point to here, and also index 1 here is also going to point to over here. Okay? Because we talk about P3 and P4. Okay? They're the same objects. And now if I highlight it, you can see that at index 1 here, and also at index 1 over here, they really point to the same objects. And for any equals method you might implement, if you're comparing two objects that are the same, it should be true, right? All right, so here, if you look at this one here, it's going to be very similar to this case over here. The only difference is now we got 0 and 1. Oh, of course, I forgot to update the count. After adding this, we should update from 1 to 2. after adding this, we should update from 1 to 2. Right? Accuracy is important. And if you try to execute this equals method here, it's still going to run this loop. But now this time, the loop counter is going to be from 0 all the way to 1, because the count is now 2 rather than just 1. Okay? So now for this iteration here, I is going to be 0 and also 1. All right? When I is equal to 0, we already did it. We're comparing this object here and this object. They're the same. When I is equal to 1, we are basically comparing this object here and this object here. Again, the same objects. And we know pretty well in the person class, it's actually going to, so when I is equal to 1, it's going to return true for us. It will be P3 equals P4. Right? This is Y. It's going to return true. All right? Let me just write one more thing for you. So in the second iteration over here, we are going to compare basically PC1 dot persons at index 1 dot equals, and then I'm running out of space. I'm going to write here, PC2 dot persons at index 1. So it's not the most organized, but you can see 1 here and also 1 here. Right? We are really comparing index 1. So index 1 is pointing to this. Index 1 is pointing to this. So they are the same. That's why equals here is just going to return true. All right? That's how you trace. All right? So that's what I want to say for this example here. Any question? Any part that's not kind of clear to you? All right. All right, let's now take a look at the final part. Okay? The final part just is a very small extension. So far, we are comparing the two person collector with just the same person. Same person, oh, well, I say equal person, that might be better. Equal persons at index 0, equal persons at index 1. But what if we got some persons at index 2, they are not equal to each other? What's going to happen? All right? Let's now consider the last possibility. And this one here, pretty short. All we got to do is we got PC1 and PC2. Now we're going to add using anonymous object here. So you can see A and A, A and A, but you can see these two values are already different. That means if we add these two persons separately into PC1 and PC2, when we compare equals again, it's going to fail. Right? Just to show to you, this one here and this one here, right? They are different. So what's going to happen? Okay, so far we already added two persons, right? P1 and P2, and also P3, P4. It's from the previous page, right? That's why we got already quite complicated diagram already. But we just add one more extension. Let's now create, let's say, this person first. That one there is going to be A, 175, 1.75. And this one here is going to be A, and also A, 165, and also 1.55. And let me highlight right away. You can see, for example, this part here and this part here, they are different already. All right, let's now add them to the collector separately. So I'm going to add the person, let's say 1 here and 1 here. So for PC1, index 2, rather than pointing to null, is now going to point to this person over here and update the count to 3. What about PC2? So PC2 at index 2, rather than pointing to null, is now going to point to here and then update the count to 3. Right? And you can see one is this one here. The other one is this one here. And they are different. Okay, finally, if you try to call the equals method here, PC1 dot equals PC2, right? That's the final thing we're going to trace. If you say PC1 dot equals PC2, we are actually going to call this version here for sure, and then we are also going to run this loop for sure. And right now, you can see NOP is 3. So that means the I value for the loop counter is going to be 0, 1, and 2. All right? We have already seen iterations for I counter 0 and 1, but this is the main point to look at. Okay? In the first 2 iterations, the equal result will just be true. But now in the third iteration, let's see. So now start the third iteration. Let me just copy that expression, and we should be done pretty soon. So you're going to say equal will be equal to, this is PC1 dot persons at index 2 dot equals. And then other would be PC2. PC2 dot persons at index 2. All right, again, you can see that we got 2 here and 2 here, corresponding to iteration number 3. All right, let's look at the diagram. PC1 dot persons at index 2. PC1 persons at index 2 is pointing to this object here. So we are comparing this object dot equals PC2 persons also index 2. So PC2 persons also index 2, and this person. So now we are basically saying this person dot equals this person. It's going to be false because this number here, for example, and this number here, they're not the same. They're not the same person. So now we are encountering the very first person in between the 2 person collector. They are not the same. All right, so here, and this one here is just going to give you false. As soon as you got equal being false, you're actually going to have the equal over here being false. So the conjunction here will be false. You got to exit from the loop, and then you got to return false. All right, a little bit dry, I agree, but it's got to be done. Any question? Yeah, so far what we have done today might be the most detailed tracing we have to do today, because we really have to see how the equals method can be executed, especially if you got array involved. That's so important. All right? All right, if no more questions, I would suggest we do a little bit of call by value background and some example, and then we can take a short break. But we still have time. Okay, why don't we do a little bit more? All right, guys, final call. Is there anything about the equals method so far that's not clear? You want me to? We do have some time for extra clarification if you want. So after today, I would suggest if you go back to the slides, we are done with everything for that lecture there. Person collector is done. So you want to play with this particular source code, which is already on the lecture site. Take a look. And then I would suggest use debugger and breakpoint to run through this test case. You can see this is a very long JUnit test case, which I broke it down into 4 different parts, which we just went through. You want to do it on the paper and also do it on Eclipse to really make sure you kind of agree with the 2 different approaches, how you do tracing. That part has to be done by you. All right. And you can also go back to your lab 0, and then you remember the refurbished store. You actually got products, you got entry, you also got refurbished store. How do you override the equals method there? That could be some interesting exercise for you to try. All right? If no further question, I would suggest we move on just for another 10 to 15 minutes, and then we'll take a short break. Okay, that will be a different topic right now, slightly different. But we still have to come back to the equals briefly, just to connect, make some connection. But this lecture here is about aggregation composition. That will be the last lecture before inheritance. But today, I think I may not reach both of them. either of them, but I might just want to talk about call by value first. And then I can do both of them quickly on Thursday. And then we should be able to touch upon slightly inheritance. All right, we're going to learn about call by value. That's really the main thing for today, especially how the call by value is going to work consistently between primitive versus reference values. And aggregation composition, I'll leave that for Thursday. Right? For now, you don't need to worry. All right, call by value. Basically, you have to brush up two sets of ideas. First set, what is parameter versus arguments? We spoke about the distinction when we review basic OOP. Right? Parameter versus argument, number one. And number two, you also want to, let me just see the example here. Parameter and argument. Let's talk about parameter and argument first, and then I'll get to the second one. Okay. Let's say we got actually a call over here. Okay, this will be the second one. That'll be a natural transition there. If I'm calling this method here in somewhere, that context there is called a caller, right? And the method that's being called over here is called a callee. And we talk about caller versus callee when we introduced to you the idea about exception. All right, so two sets of idea. Number one, argument versus parameter. Number two, caller versus callee. We're going to need these two ideas. Okay. And this slide here, you can go through, but I'm going to talk about examples right away. Let me sketch some example idea. Let's clarify terminology once more. Might be nice review. You can see that we are now trying to make a method call over here. This is a method call. And what we said earlier was every time you see a line of method call, it's going to indicate some caller-callee relationship. You can see here the N is a method from class A because the context object CO is of types A. So from here, we know that this is the callee, which is A dot N. This is the method that's being called. And the context where this method call is being made is the caller. So you can see we are making this method call within the method N that's in the class B. So this one tells us the caller is actually B dot N. All right, this is something we learned earlier. Caller, callee. And what about parameter versus arguments? The parameter is basically the definition of the method on the callee side. So you can see here, this is the declaration of the callee method. And here I just call it param. And then you got to give it a type. Right? Think about a param, it's just like a variable. And the variable scope should be within that method only. You cannot refer to the parameter of one method in another method. Right? We also spoke about it earlier. Final point to make, you can also see this will be the concrete value we want to pass in order to call the callee. So this is some concrete value used to call the callee. Right, recap. Just from this line, we know that the input that's being passed over here is called arguments. And the definition of that method there is called a parameter. And also we talk about caller is the context where you're calling this method. And the method being called is called callee. Right? And if you are clear about this terminology, now we can talk about call by value. The call by value definition is actually very simple, but we just need examples to really reinforce our understanding. So here comes the definition. I'll write it down first, and I'll give you some visual. Call by value. Okay? When making a method call, there is an implicit. Implicit simply means you don't really write it yourself. It's actually done behind the scene. Variable assignments. And that one is the parameter is assigned to the arguments. And notice that the order is very important. Okay? Implicit. Now, how do we visualize this? Now, we are trying to actually make this method call here. This is a method call. And we want to connect it with the definition of that particular method. And the way we're going to connect them together is by something called call by value. And you want to understand it as param over here is going to make a copy. I'll try to write maybe not to be so blocked. Okay, how about I'll put it here. Param is assigned to arc. This will be the definition, which might still seem a little bit abstract, but we're going to see an example. That's the only definition you have to know in order to understand call by value. Just remember, whenever you got the method call, like this, you can trace the method call back to the declaration of the method being called, and then the parameter value is simply just a copy of the arguments. And now, there are two cases for us to consider. Case number one, what if the parameter and arguments are primitive values, like an integer? Case number two, what if the parameter and arguments are reference types, like a person or circle or whatever? Okay, let's talk about these cases one by one, and then we'll take a very short break. All right? Any questions so far? All right, so let's now take a look. All right, let's now take a look at the call by value primitive type. So here we are considering this method call here. We want to set a radius of some circle. And the set radius method was declared over here by the definition of call by value. Let me just connect them here. And then I'm going to write it down. So call by value tells you that the parameter r is simply assigned to the value for arguments. This is something I want to write down right away. So when we do the code tracing, we can see what effects that call by value is going to have on our code tracing. All right, let's now take a look. Now I can trace the code over here. Number one, I'm going to create a circle. So C is pointing to a circle object over here. And then let's say the radius has the default value 0. And then I have some integer arguments. It's a primitive type. You just got 10. So think about it's more like a box. And then argument has the value 10. That's it so far. And then we're going to somehow use the argument value here to call this method. We want to set the radius C here to be 10 somehow. But how do we do that? So when we make this method call, what's going to happen is we're going to switch the context we'll step into. We're going to step into this method that's being called here. And then we're going to now want to trace the code rather than in terms of arguments. We want to trace the code in terms of R. How do we do that? R is like a variable of type integer. Sorry. Integer. And then call by value rule tells us we're going to do this assignment here. R is assigned to arc. R is assigned to arc. That means copy 10 to here. It's a very critical step for you to see. All right? So now when we trace the rest of the code in the callee, we are not going to be concerned about arc here anymore. We only worry about this copy here for the parameter. Because as you can see, it's a separate copy. Whatever you do over here, it's not going to impact over here, as you can see, right? Finally, if you try to trace this code here to say this radius, so C is the context object. So C radius will be R. R is 10. So we're going to change that to 10. This is call by value, how call by value works in case of primitive type, which is not tricky, right? Just a copy. So now we're going to consider what if the argument is actually a reference variable. Call by value rule doesn't change. We still want to assign the arguments to the parameter. But now what should we copy in this case? Do we copy the entire objects or something else? What does it really mean when you got an equal sign between the two reference variables? You copy their address, exactly. All right? Let's now take a look at this example. After this one here, we can take a short break. All right? How do we visualize this? This one here is basically set a radius, but now the argument here is not integer anymore. It's now a circle. All right? And then we're going to invoke this method here where the parameter is also a reference type. Right? Let's now visualize this together. Okay? But before that, I can show to you calling this method here corresponding to this method over here. This is the arguments. This is the parameter. And then if I want to draw some connection between them, it's going to be call by value. So call by value over here tells me it should be C is assigned to arg. This is so important for you to see. All right? You can see the same pattern over here. But now, what does it really mean when I say C is assigned to arg? That means C is going to point to wherever arg is pointing to. Aliasing. All right? Let's now see exactly how it's going to work. This line here, we're going to create a new circle. And that one there, as before, is going to have the default value for radius 0. And then we're going to create another circle, which will be the arguments. So the arguments is going to be just another circle over here. And then that one there, also type circle. But now this time we're calling a different overloaded version of the constructor, which will set the radius to be 10. So R here will be 10. So far, so good. So we've got two objects so far. And what we do now is we want to say, I want to set the radius of this circle here to be the radius of this circle. That's what I want to do. So I call this method here by passing arguments. According to call by value, if I now step into the method call here, I need to first do this implicit assignments. And how do I visualize it? There's going to be the parameter C. And then C is going to point to wherever argument is pointing to, like here. Once this assignment is done, for the rest of the code tracing within the context of this method, we're going to focus on just C. Argument is no longer our concern. All right? And then over here, when you say this dot radius, which will be here, should be C dot radius. C is pointing to here. The radius is going to be changed to 10. Right? But this example is still very simple. I just want to show to you how call by value is going to work. The method here can be more complicated, which I'm going to show in the second example. Any question? Before we take a break, you want to think to yourself. In the case of the primitive value here, if I change this value maybe from 10 to 20, this one remains to be 10. There are different boxes. Now, let's say this C here is an address value. If I say C is a reassigned to null, for example, is it going to modify ARG? Not really, because that one is only going to reassign this one here to be null. Whereas arg is still pointing to these objects. All right, that's case number one. Case number two. Let's say I don't want to reassign C to be something else. Keep it. But I might say C dot maybe set radius to be 20. In that way, is this 20 here also impacting ARG? Yes, because ARG is pointing to the same objects. So there are two cases we're going to talk about for call by value. One is just reassigning the reference, which will be useless. The other one is to invoke a mutator on the parameter. That one is going to cause some impact, which you're going to see. All right, why don't we take a very short break by taking attendance? Okay, just have your mobile device ready, and then, okay, two more things I would like to do. I want to go over just another example there to illustrate the effects for call by value for primitive versus reference type, and then I want to draw a quick connection to equals method. All right, let's do that. All right, I got three different cases to talk about. Okay. All right, case number one. In the callee, I got utility class, and then that one there is a method called reassign integer. What it does is it's going to take the primitive value parameter, reassign that to j plus 1. Okay? And then let's now test this right away. The caller is trying to execute this line. Let's now trace them right away. Utility has no attribute, so we don't need to draw the box. And then we got I here has the value 10. Primitive. And then we want to make sure I is 10. Of course, he's going to pass. And then we're going to have this method call, which corresponds to this method over here. And if you want to draw the connection between them over here, it's going to be call by value. So call by value tells you that j, the parameter, is assigned to the argument I. This is so important for you to remember. All right? We're going to do it another 2 times, right? Okay, this one here. Oh, let me use maybe a different color here. It might be more emphasizing. There we go. This one here. J is assigned to I. And now how do we trace it? The way to trace it is, now j here is going to be another integer variable here. Again, that's poor drawing. And then it's going to be a copy of I, which is 10. Separate copies. And then when we try to execute this line here, j is assigned to j plus 1. So we're only modifying this one to be 11, whereas the original copy as the arguments here doesn't change. That's the main thing for you to see. And then after this, if you say assert true, that I remains to be 10. That's true. So I is untouched. I is untouched by the method. All right, that's example number 1, call by value. All right, if no question here, let me move on to the next one. Now let's talk about reference type. 2 cases. Okay, case number 1. In this method here, reassign ref is pretty explicit about what it is going to do. We got parameter q, which is reference type. We create some local reference objects, and we reassign q to be something else. That's what it is trying to do. All right? Let's now try to trace the code. And here I'm just including a definition for the point just for your information, but pretty straightforward, just x and y. Okay? And when we get to this line here, so we got point P, which is a new point over here. And then that one has x and y, 3, 4. X and y, 3 and 4. And then we got another reference over here just for later assertion. This one say, whatever P is, copy that over to ref before P. So that's the ref of P before, just an alias. Okay? Because we want to do this just in case if for whatever reason P got assigned to something else. In that case, these 2 references will not be the same. Right? That's actually just for some assertion purpose only. And then we're going to see this line here. and this line over here. The way to trace it, before we even start it, we're going to connect them using call by value. These two. So call by value tells you that. So call by value tells you that you got to do the assignments. Q, the parameter, is assigned to P, the arguments. This is the most critical step to get right. That's the most critical one. And this one here, how do we visualize it? You basically got point Q. And that one there is going to point to wherever P is pointing to. So we are effectively creating an alias over here. And then when you try to keep going, for the rest of this method here, we are now going to focus more on the Q, the parameter. And first of all, we got some local object here, MP. So MP is pointing to some new point objects. That one there got 6 and 8. X and Y, 6 and 8. And then this line here tells you I want to reassign Q into MP. Q, rather than pointing to here, is going to point to MP over here. All right, that's what's happening. And now, the only thing you want to ask yourself is, by changing Q from here into here, does it impact P? Not really, because they are separate copies of the same address. So that's why after the method call, you can see P here remains to be this object here. So the most important thing is you want to say the value, address value of P stays the same. The only thing that we change is the Q, which is parameter. It's a different variable. All right, call by value. We good? Okay, one more scenario, and then I should be able to make one more connection to equals, and then we're done. All right, so this case over here is actually not very uncommon. You might see your classmate or yourself. Sometimes you may want to say, well, I'm giving this parameter here. I want to reassign that to something else. Don't try that. It's going to achieve what you want them to achieve. Because after calling this method here, you might be expecting that P should be reassigned to maybe something else. No, it's not going to do that. The only thing it's going to change will be the copy, the Q here, because of call by value. That's the main lesson for you to see. All right, final scenario here. So this is the only scenario where you can modify slightly. Well, I shouldn't say slightly. That's the only way you can modify the objects that's being shared between the parameter Q and the argument P. That's the only way. Let's see. So we are talking about this method here, change by ref, and also change by ref. So these are the two. And then, even before I start tracing, let me just put them together. And then, the way they are connected is by having that implicit assignments. So, call by value. Q is assigned to P. And once you get this one clear, the rest should be quite straightforward. But let's still do it. Let's now try to trace line by line. This line here, we got P here, pointing to a new object here, point 3 and 4. X and Y, 3 and 4. And then we got another reference over here. So that's the reference of P before, pointing to the same object. So the setup is really the same. And then when we try to trace this code over here, we now switch the context to this method here. And now we already know, because of call by value, we're going to make sure Q is now a copy of P. So let's now create Q. So Q is really a copy of P. Right? Call by value. And you can see here, the two lines over here, what we're trying to do here is different. we are just calling mutator method on Q versus we were trying to reassign Q to be something else. When you study, you want to pay attention to these two differences. Okay. So now when I try to say Q that move horizontally, we are incrementing the x value by 3, and etc. So when I say Q here, move horizontally by 3, so Q, follow the link, you're going to modify from 3 to 6. And also move vertically, you're going to modify Y. So again, by Q, I go to here and then modify to 8. Now, here's a critical question. By using Q to make modification to this object here, is it going to impact what P can see? Indeed, because they are pointing to the same objects. And you have some question. Oh, you're going to say that. Okay, good. I just answered for you. All right. That's really the aliasing, right? So call by value has been happening consistently. You just have to see whether it's a primitive type or reference type, right? So this one here is definitely, after this, if you try to look at the assertion here, X and Y for P just become 6 and 8. 6 and 8. All right? That's about call by value. Any question? Okay. One more thing, and then we're done. Just one more thing. Let's now revisit the equals method. All right? The way we trace the equals method, which I taught you before, is almost 99% correct. Except there's one more detail I think we should add, now that we know about call by value. Let's now take a look. Let's say we got our P2 and P3, right? Point V2. So 3, 4, 4, 5. So 3, 4, and 4, 5. And let's now try to look at this method called P2 that equals P3, which refers to this equals method over here. And before we start tracing, let's connect these two together. And we know that the way to connect would be parameter OBJ should be assigned to P3, the arguments. Right, we're doing the same pattern. This is call by value. And once you get it right, you're done with almost half. So when we try to now trace the code for the rest of the code, you can see whenever we are referring to, let's say, OBJ, just let me do that tracing. So after I do this assignment here, that means OBJ is going to point to over here, the same object as P3 is pointing to. The only difference is this. You can see P3 here was declared to be of static type point V2. On the other hand, if you look at the object over here, OBJ, the OBJ has the static type objects. So this is why whenever we are trying to execute a code, we cannot really say obj.x and also obj.y. It simply wouldn't compile for the reason that we discussed earlier. So the only way to really fix it is really by casting your OBJ over here, which is really pointing to point V2 objects into point V2, right? So now you can connect the story from before. So what I'm adding here as extra detail is to say whenever you're calling the equals method, call by value still works the same way. You're just saying the object parameter here now is a copy of the argument object P3. So OBJ is really pointing to here, the same. The only thing you want to really connect to earlier story is OBJ, the parameter is object type. So you cannot call any obj.x, obj.y. That's why you got to do type casting. All right, any question? All right, so today we only did two things. Number one, person collector tracing. Number two, call by value. All right, Thursday, we're going to talk about aggregation composition, and hopefully I can motivate a little bit about inheritance. All right, I'll see you tomorrow in your test.